Hello, and welcome to another video of Renesas Timing University. I'm Steven Gutierrez. In this video, we're going to be talking about how to debug deterministic jitter. In a previous video, I explained how it's observed in the time domain and the frequency domain. In this video, I want to do just a follow-up to kind of give you some hints on how to figure out what the source of the deterministic jitter is. So let's say you have a signal that's showing in the time domain some deterministic jitter, or maybe a spur in the frequency domain. My first suggestion is that you look at the signal under ideal conditions, meaning if you have an evaluation board, measure the device under that condition, or you can ask us for measurement from our lab. That's going to help you understand if that deterministic jitter is actually present inside the device. So let's say the signal or the measurement results in you don't really see the spur. Okay, so that means it's probably coming from the board somewhere. Let's start debugging that. I would start by looking at the power supply and other signals on the board. So what you can do is turn off other signals on the board, turn off other devices, and only power up the device that you want to test. Now, if you still see the spur, then most likely it's coming from the power supply. In that case, what I would do is I would turn off the power supply and use an external lab power supply to provide clean power to the chip. At that point, you should be getting a clean signal. Then I would power up the rest of the board and see if perhaps that power supply was the cause of the noise. So let's say it was the cause of the noise, then you can focus on the power filtering or maybe consider an LDO to help reject that noise. Let's say it was not the power supply. So maybe it's some other signal on the board itself. So what I would start to do next is turning on one signal at a time and trying to isolate it and figure out what other device that you turn on is going to cause that spur to show up. Now, let's say you isolate it and you figure out, oh, when I turn on this other chip, I can see noise coming into my device. At that point, you can manipulate the other chip, trying to see if you can change the spur level. For example, you can change the amplitude of the signal of the other device, or you can change the frequency of the signal of the other device. Once you make changes to the other device and you can determine that there's a correlation between that change and the spur level, that now means that you've identified what the source of the noise is. At that point, you can take a look at the layout and see where the two signals are coupling. So these are just quick tidbits on how to root cause deterministic jitter. And again, if we don't see it under ideal conditions, it's coming from somewhere on the board and we can figure it out. So I hope this video has been helpful for you. And we also have another video that shares on the root causes of deterministic jitter. So go ahead and check that out. And I also encourage you to check out more of our videos on Renesas Timing University.